Hello students, today I am going to start a lesson of class 8 mathematics, that is rational numbers. Rational numbers. In this topic, these many points to be discussed here. Types of numbers, definition of rational numbers, laws of rational numbers, properties of rational numbers, representation of rational numbers on number line, rational numbers between two rational numbers. These many points we are going to discuss. Very first one is types of numbers. It's a very easiest thing. Since beginning you are learning this. Definition of natural numbers. The counting numbers are called as natural numbers. That is 1, 2, 3, 4 and so on. Next is whole numbers. See, the number 0 together with natural numbers gives whole numbers. Here see 1, 2, 3, 4 are natural numbers. Together with 0 it makes the set of whole numbers. And 0 is the smallest whole number. Integers. See definition. See integers is a set of numbers in which negative numbers are also there and all whole numbers are there. So definition says that a combined set of negative numbers and whole numbers is called integers. Here see, from negative infinity, -4, -3, -2, -1, 0, 1, 2, 3, 4 and so on. In both the sides there is no end for numbers. There is no smallest integer. See here, -1 is greater than -2. -2 is greater than -3 or -3 is less than -2. When we keep on moving toward the left hand side, we get the smallest numbers, but there is no end for smallest numbers. So we can say that there is no smallest integer. 0 is neither positive nor negative. Means it has no any sign with it. It is neither positive nor negative. 0 is greater than all negative integers. Here, 0 is greater than all the negative integers, but 0 is smaller than all the positive integers. Rational numbers. Rational number is nothing but the ratio between two integers. In simple language, I can say it's the ratio of two integers. See, definition says that a number which can be written in the form of p by q, where p and q are integers and q does not equal 0. Here is a condition, q does not equal 0. If q becomes 0, then it is undefined. So, this is the definition of rational numbers. Here are some laws which already we have studied with whole numbers, natural numbers and so on. Here also we are studying with the same laws with rational numbers. Closure law, commutative law, associative law, distributive law, existence of additive identity, existence of additive inverse, multiplicative identity, multiplicative inverse. So, the very first law, closure law. Here, if A, B, C are any rational numbers, let us study with the with some examples, and we will decide whether it is applicable for closure law or not. Here see, addition. A plus B is a rational number. If A and B are any two rational numbers, then their sum must also be a rational number. Here is an example. -5 by 12 plus -1 by 4. Here 12 is LCM and then on simplification lastly we will get -2 by 3, which is also a rational number. Then second, subtraction. Means A and B. If A and B are any rational numbers, then their difference must also a rational number. Let us see that. Here is an example third. -27 upon 36 minus 14 upon 36. Here LCM is 36 and so on. On simplification we will get -41 upon 36, which is also a rational number. Hence, subtraction of rational numbers satisfies closure law. Multiplication of rational numbers. Here -4 by 5 minus 6 by 11, two rational numbers and their product I have taken here, and then as a product I will get 24 upon 55, which is also a rational number, hence it is satisfied. Now comes the question about division. What happens here? Here example is not there, but I explain here. See, let us take two rational numbers, say 4 by 5. It's a rational number, but if we consider denominator as 0, because 0 is also an integer, 2 by 0, which cannot be defined, it is undefined. Hence, division of rational number need not be a rational number sometimes. If it is denominator 0, then it is undefined. Next is commutative law. Commutative means what? A plus B must equal B plus A. Here, if A and B are any two rational numbers, then for addition, A plus B must equal B plus A. Means commutative law satisfies for rational number or not. For that, we need a example. Here, 5 by 6 plus minus 4 by 9. This is the sum of these two, and here addition is done. Then LCM is 18, then minus 15, then 7 by 18. And minus 4 by 9 plus 5 by 6. This is also 7 by 18. So these two are equal. Hence, the commutative law satisfies addition, or addition satisfies the commutative law of rational numbers. Now let us come to subtraction. So A and B are any two rational numbers, then A minus B must equal B minus A. Whether it is possible or not, we have to see with the example here. See, example second. 2 by 3 minus 1 by 6 is equal to, on simplification, at last we get 1 by 2. Am I right? Then, in the same way, what we must do? B minus A we have to find. On simplification, at the end we will get minus 1 by 2, which are not equal. Hence, subtraction does not satisfy for commutative law does not satisfy subtraction of rational numbers. Then third one is multiplication. A into B must equal B into A. Here commutative law, it is called commutative law. It satisfies or not. With an example we can see here. 3 by 4 into 5 by 7. On simplification I get 15 upon 28. Here 5 by 7 first, then 3 by 4. On simplification I will get the same answer, hence it satisfies. Now comes division. Division is not commutative because here with example we can verify. Minus 5 by 4 divided by 3 by 7 is equal to. So when we take the reciprocal, we have to take 7 upon 3 and minus 35 upon 12 get here. In the same way, 7 upon 3 divided by minus 5 by 4, on simplification I will get minus 12 by 35. These two are not equal. Hence, it is not satisfied. Now let's come to the associative law. Associative law, for any number we need three numbers, right? So here A, B and C are any three rational numbers. Let us see A plus B plus C is equal to A plus B plus C or not with rational numbers. So here, for example, 1, 2, 3. Three rational numbers I have taken. Minus 3 by 4 plus 5 by 6 plus minus 4 by 9. On simplification, what I will get? At the end, minus 3 by 30, minus 13 by 30. Here, I will group in different way. First two I will group and then last one be free. And at the end of the simplification, I will get the same answer. So, associative law satisfies with rational numbers. Second, subtraction. If A, B, C are any three rational numbers, then it is satisfying or not. We have to see the example. Here minus 2 by 3, minus 4 by 5, minus 1 by 2. These all are the three examples what I have taken here. So on simplification at the end here I will get 19 by 30, and at the end of simplification I get here minus 7 by 30, in which we observe that both are not equal. They are not equal. Hence subtraction does not exist. Multiplication exists because addition and multiplication are connected, children, right? So this is applicable or it is satisfied, but division does not exist. Distributive law. Here are two laws. One is distributive law over addition, distributive law over subtraction. If A, B and C are any three rational numbers, then A into B plus C is equal to A into B plus A into C. Whether it is satisfying or not means verifies both the sides LHS equals RHS or not, we will see here. We have here example 2 by 3 minus 3 by 5 and 7 upon 10. These are the three rational numbers. Then accordingly I write here A into B plus C. So A into B plus C. 2 by 3 into minus 3 by 5 plus 7 upon 10 is equal to, on simplification at the end I will get 1 by 15. Am I right? In the same way I will take B minus C. 2 upon 3 into minus 3 upon 5 plus 2 upon 3 into 7 upon 10 means it's multiplication of the bracket here, right? Then I'll get here at the end again I will get the same answer, 1 upon 15, both the sides. Am I right? Hence it satisfies, right? Means A into B plus C is equal to A into B plus A into C. Hence it is satisfied with distributive law, satisfied with over addition. Means distributive law of multiplication over addition satisfies with rational numbers. Next, existence of additive identity. Existence of additive identity means rule of zero. See children, not only rational numbers, any number you take and add 0 to it, there is no change in the value. So A plus 0 is equal to 0 plus A. Then ultimate answer is A. So 0 is called the additive identity of A. For example, 2 by 3 plus 0 is equals 2 by 3. In the same way, 0 plus 2 by 3 is also 2 by 3. Existence of additive inverse. Children, please carefully learn this. Inverse means just opposite sign. If it is plus, that will be minus. If it is minus, that will be plus. So, existence of additive inverse or negative of a number. See here, A plus of minus A is equal to minus A plus A. In both the cases, the sum is 0. Hence, minus A is called additive inverse of A. Here is an example you can see. The additive inverse or negative of 3 by 5 is minus 3 by 5. If it is given number is minus 3 by 5, its additive inverse is 3 by 5. Okay. Next, multiplicative identity. Children, 1 is the number which is when it is multiplied to any type of number, there will be no change in the value. Hence, multiplicative identity is 1 for any type of numbers. Likewise, here also rational numbers. So, A into 1 is equal to 1 into A is equal to A. 1 is called the multiplicative identity of A. Multiplicative inverse. Inverse in the sense, there is one more word for multiplicative inverse is reciprocal. means numerator becomes denominator, denominator becomes numerator. Here see, a into 1 upon a is equal to 1 upon a is nothing but multiplicative inverse of a. So 1 upon a is equal to a. The total answer is, or simplified answer is 1. 1 upon a is called the multiplicative inverse of a. Here are so many examples. 8 upon 21 should be multiplied by 21 upon 8 to get the product 1. When we multiply those numbers, we should get 1 as the ultimate answer or final answer. Such numbers are called as multiplicative inverse. So here a by b into c by d must equal 1. Okay, this is called as a rational number c by d is called a reciprocal or multiplicative inverse of another rational number a by b if there is a condition the product of those two must equal 1. Fine. Next, properties of rational numbers. All whole numbers, integers and natural numbers are rational numbers. Why we call them as rational numbers? Any numbers like whole numbers, integers and natural numbers, we call them as rational numbers because we can make them in the form of p by q by writing their denominator as 1. All rational numbers are not whole numbers, integers and natural numbers. So, all rational numbers are not whole numbers. How can you justify this? So, denominator if it is 0, then what happens? It is undefined, right? Okay. There are infinitely many rational numbers between two rational numbers. This is a very important thing. When we take any two numbers, in between there are infinite number of numbers. Next. Okay. Today I want to conclude my class, and homework for you is to give some examples to justify the distributive law of multiplication over subtraction for rational numbers. So try 5 examples, take your own examples and then justify it yourself. Okay. Thank you. Take care. Bye bye.